All right, so we're going to look at number 23. And so this is from the practice test 1, section 3.2. It's 3.2.38 if we want to get that question identifier. Babies born after 40 weeks of gestation have a mean length. So we're looking, there's actually two different categories in this data. 40 weeks of gestation have a mean length of 52.4 centimeters. Okay, so that's one piece of data we've been given. Babies born 1 month early have a mean length of 47 centimeters. And that makes sense, right? Because if the gestation period is 40 weeks, so, you know, a normal gestation, I'm assuming then would be the 40 weeks. Then what we're getting is the X bar equals 52.4. Now, the other data set that we've been given is that babies born 1 month early, so 1 month early, or I guess about, so if 1 month's forward, it'd be about 36 weeks, but we're not going to go into all that. They have a mean length X bar equal to 47 centimeters. So, I mean, you would expect them to be less. Assume both standard deviations, so they have the same sigma, or same S in this case, because it's a sample, would be 2.4. And then on the right, again, S equals 2.4. And the distributions are, it should be R, unimodal and symmetric. So again, like we kind of know that's what we're working with right now. We're not dealing with weird symmetries or anything, but this is important because once again, if they're unimodal and symmetric, if they have that bell curve, we've seen it a few times now in a row, then we can use the empirical rule. We can use our z-scores, and you know, we have some information that we know about this. Okay, so coming down here, we know information from this. We can calculate the standardized z-score. So that's part A. So let's look at this. So for part A right here, let me get a different color. Okay, I guess that looks good. Find the standardized z-score, standardized score, relative to babies born 40 weeks of gestation for a baby born with length of 45 centimeters. And then we're going to do the same thing again for a baby born 1 month early using 47. So I kind of looked at it and kind of had an idea what I was going to do. So I set the two up. For me, it's easy if I break things into parts like this. But for both of them, I am going to use that same z-score formula that we've been using for a while. So z-score is going to equal X minus X bar over my S. Okay. So I'll do part A first, which is 40 weeks. So that's going to be part A. For that, my X is going to equal 45. They both equal 45. So for part A, I'm going to say 45, which is my X, minus my X bar, which is 52.4, and divide it by 2.4. And that's going to give me my z-score. So z is going to equal, let me run this calculation real quick and hope I do it correctly. Why don't you, if you want to, you could pause it and try it. And you could maybe go ahead and get that score and then go ahead and maybe try doing the other calculation for part B, because it's very similar, right? So for part B now, we're going to do X is equal to 45 as well. So this is part B over on the right. So maybe try both if you wanted to, you know, try it on your own. But I'll go ahead and do it here while you want to pause and see. Okay. And round to 2 decimal places. And they did say in the notes is typically 2 decimal places for these. So z equals negative 3.08333. There's a bunch of threes. So I would round that to just 3 points. So z is going to equal negative 3.084 part of it. Okay, go ahead and do it for the next one. So z is going to equal 45 minus 47 over 2.4. So in this case, z is going to equal that would equal negative 0.83333. So then rounding that to 2 decimal places is negative 0.83. Okay, so I've got my 2 z-scores. I'm going to plug them in above. Negative 3.08, negative 0.83. So let's look at this. So now that we have the numbers, we want to interpret it, right? For which group is a birth length of 45 centimeters more common? Explain what that means. And they've given you a helpful hint here, right? So this is always nice. Let me see. Good. unusual z-scores are far from 0. Now, when we say that, we're talking about absolute value, right? Like we're talking about the distance that it is from 0. And if you think back to our bell curve, and again, I'll try and draw it. I don't know how I'm going to 11. So I'm going to draw, like, I have it like this, and if this is my x bar, I'm going to use, again, I like my little crayon because it doesn't look so bad. What they're saying is, how far away is it? So look at our values that we had. And I know that these are a little different because they have different means. But if you think about it, this one has a z-score of negative. So it's about 1. This would be negative 0.83, right? And then the other one, and again, they shouldn't be on the same graph because they don't have the same name. But I'm just going to give you a sense, like think about a number line, maybe how far away it is from 0. So let's get rid of that then. Let's make this 0, just because I don't want to confuse anybody. I'm going to say I told you to do this. So if that's 1, that's about negative 0.83. I'm going to make it a little easier to read, right? So negative 0.83. And then, this would be 1, 2, 3. So this is negative 3.808, right? So negative, I'm going to move this. It's really hard to read because I have all this writing right here. I'll move it up a little maybe. So let's come here. Let's make a number line right here. So if I'm talking about 0, I've got 1, 2, 3. So negative 0.83 is close to negative 1. And then this one's way out here, negative 3.08. So obviously this one's much closer, right? So this one's going to be less unusual. So which case was that? This was the case of 1 month early. And does this make sense? Because we're talking about a baby that was born and it was a little short, whatever animal this was, right? 45 centimeters. And the standard length at fully gestated, I guess you would say, is 52.4. But, if it's 1 month early, it's 47. So 45 is closer to that. That makes sense. And it would make sense because, the baby wasn't able to keep growing. The longer it stays in there, the more it would grow. So a birth length of 45 is more common for babies that are born 1 month early. That would make sense. And that makes sense because babies grow. And if it was 1 month early, had less time to grow. So part B, because, that's just common sense. So that's one good thing. Statistics should always make sense, y'all. Within reason. Sometimes probability sometimes is counterintuitive for sure. But we are looking at, again, practice test 1, and this is question 3.2.38. It was question number 23 in our practice test.